Hello everybody, today we're going to talk about simplifying square roots. Okay, so when a fraction, we're going to talk about fractions first though, because when a fraction's not reduced, it's really easy usually to see if it's equivalent to another fraction. For example, 2/6 and 1/3, super easy to tell that those are the same thing. But why do we reduce? Why do we bother reducing fractions? Because it makes it easy to see that we all got the same answer. Okay, it also often gives us a fraction that's easier to work with. Usually 1/3 is easier to work with than 2/6 is. This becomes even more important with square roots because it's a lot harder to tell when two square roots are equal than it is to tell two fractions. For example, can you tell square root of 24 and 2 times the square root of 6 are the same number? That's kind of hard to see. Okay, so the question is, how do we reduce a square root? All right, so first we need to review some properties of square roots. The first one, the square root of a times the square root of b is the square root of a times b. Okay, so that would be like square root of 2 times square root of 3 is the square root of 6. Now the next property would be that the square root of a over b is the square root of a over the square root of b. So I'm going to square root both the top and the bottom. Now you got to be careful because sometimes you have something like this, and sometimes you have something like this. Okay, this just means the square root of a divided by b. This means the square root of a divided by the square root of b. Those are not the same thing. Okay, so an example of this would be to simplify this. Well, I would square root 49, and I would square root 4. So it's going to be 7 over 2. And I'm done. I can't simplify it anymore. Some are super easy to simplify. Like if I'm going to square root a prime number, square root of 17, I can't do anything to that. That's just the square root of 17. That's the answer. It's simplified as far as it's going to go. Okay. All right. It's easy to reduce a square root. Step one is you find the biggest perfect square that will divide evenly into the number that's under the square root. Okay. Then what we're going to do is we're going to divide that in there, and we're going to break that square root up into 2 square roots. And then we're going to square root the perfect square. So let's review. What are perfect squares? Well, you got 1, which is never really helpful. You got 4, you got 9, you got 16, 25, 36, 49, 64, 81, and 100. That's the first 10. Okay, you're going to look for those square roots in the square root that you're wanting to reduce. Okay, so for example, simplify the square root of 12. All right, so I look on my list. There's only 2. We're not going to use 1. We're just not going to use that. So I basically have 2 choices since 12 is like right here. I can either divide it by 4 or divide it by 9. Okay, 12 is not divisible by 9, but it is divisible by 4. So I can change this to the square root of 4 times the square root of 3, because square root of 4 times square root of 3 is square root of 12. Now, this is a perfect square. I can square root it. It's 2. This I can't do anything with, so I just leave it square root of 3. This is simplified right here. Okay? All right, simplify the square root of 32. I need to find a perfect square from my list that goes into 32. And I'm sure you guessed it, it's 16. Okay? So this would be changed to the square root of 16 times the square root of 2, because 16 times 2 is 32. All right, the square root of 16 is 4. Square root of 2, we're just going to leave it because I can't square root it. And there you go. That's your answer. 4 square root of 2 is the square root of 32. Okay, what if I've got a fraction like this? Okay, so on this one, I would break this up. Square root of 72 on top, square root of 25 on the bottom. This is easy. That's just 5. Okay, a perfect square that will go into 72. Well, the biggest one I can find is going to be 36, because 36 times 2 is 72. And then this square roots and becomes just 6. So it's 6 square root of 2 over 5. And I can't really do anything else with it, so that's it. Okay. So sometimes if a number's large, it's difficult to find the largest perfect square that will divide into the number. So in that case, we're just going to look for any perfect square we can find and divide that in there. So like 1,728, that's a pretty big number. If you can find the biggest perfect square, then you're only going to have one step to do it. But I might need more than that. So here's what I can look at. Hey, 28, remember that one of the rules is any number that the last 2 digits is divisible by 4, that number is divisible by 4. So 1,728 is divisible by 4. Okay, so I can make this square root of 4, and then I'll just divide 1,728 divided by 4. It's going to be 432. Okay, well, this is 2. All right, now here's the thing. I'm not done yet because, 32, that's divisible by 4. So I can take another 4 out of this thing. So this is 2 times the square root of 4 times the square root of, 432 divided by 4. That's going to be 108. Okay, so again, this is 2. That's 2. That's the square root of 108. So 2 times 2 is 4. Let's see. 8 is divisible by 4, so I could do this by 4 again. Here, let's do this in a different color. Let's try green. Okay, so this is 4 times the square root of 4 times, that should be 25, 26, 27. That's 27. Okay, so this is 4 times 2 times the square root of 27, which would be 8 times the square root of 27. But wait, there's a perfect square that goes into 27, and that would be 9. So this is 8 square root of 9 times the square root of 3. Well, let's see, square root of 9 is 3, so this is 8 times 3 times the square root of 3, which is 24 square root of 3. Okay, I can't find a perfect square that goes into 3 except for 1, and that doesn't help me, so that's as far as I go. Now, if I had been lucky, I could have done this in one step. If I would have seen that, the square root of 1728 has a perfect square of 576. Okay, times 3. Well, the square root of 576 is 24. So I could have done this in one step, but most people aren't going to jump on that right away. You might have seen that 16 would come out of here, and you could have jumped out of that a lot earlier. Let's see, does 16 go in there? 1728 divided by 16. Yeah, 108 times. I could have jumped clear down to here. But, just find a perfect square and take it out. And then if there's another perfect square, take that out and just keep going until you're done. Most of them do not take this much. Okay, so here's what you're going to do is you're going to pause the video. You're going to go ahead and simplify these square roots. Then you're going to jump back on here and see how you did. Okay, so the square root of 27, that's the square root of 9 times the square root of 3. And 9 is the perfect square. That's just 3. So this becomes 3 square root of 3. Okay, square root of 98. That's 49 times 2. And the square root of 49 is 7. So this is 7 times the square root of 2. Okay, square root of 288. You might do the 4, take a 4 out of there, but this is one that if you look at it, 144 will go in there twice, and that's a perfect square too. That's not a hard one to see. So that's 12 times the square root of 2. And then you've got the square root of 4,000. Well, let's see. 100's a perfect square. I could make this the square root of 100 times the square root of what? 40. Okay, so this would be 10 square root of 40. But you know what? 4 will go into 40. So this is 10 times the square root of 4 times the square root of 10, because 4 times 10 is 40. Oh, and then that's 2. So this is 10 times 2 times the square root of 10. And 10 times 2 is 20 square root of 10. That's my answer. Or you might have noticed, I could have done 400. The square root of 400 is 20, and that would have left 10. Okay, so hopefully you got all 4 of those correct. Okay, multiplying numbers with radicals. So if you're multiplying numbers of the form a times the square root of b times c times the square root of d, you are allowed to multiply any numbers that are outside the square roots, and you're allowed to multiply any numbers inside the square roots. What you can't do is multiply a number outside a square root with a number inside the square root. So basically on this, I can take a times c, and then I can do the square root of b times d. Okay, so for example, let's look at this one. 4 square roots of 2 times 2 square roots of 3. Well, I can multiply the 4 times 2, that's 8. And I can multiply the square root of 2 times the square root of 3, that's the square root of 6. And I'm done because square root of 6 is simplified as far as it's going to go. Okay, 5 square root of 6 times square root of 3. Well, remember there's an imaginary 1 out here. So 1 times 5 is 5. So I'm going to get 5, and then I'm going to multiply these two because they're both inside the square root. Now that's the square root of 18. Now here's the thing. Square root of 18 is not simplified. So the perfect square that will go into 18 would be 9. So this would be 5 times the square root of 9 times the square root of 2. And the square root of 9 is 3, so this is 5 times 3 times the square root of 2, which would be 15 square roots of 2. Okay, why don't you pause this, give this one a stab, and see how you do. Okay, so on this one, we can go 7 times 2 is 14. And we can do square root of 8 times square root of 5 would be square root of 40. Now, 4 is a perfect square that will go into 40, so this is 14 times the square root of 4 times the square root of 10. And remember that square root of 4 is 2, so this is 14 times 2 times the square root of 10. And that's going to be 28 times the square root of 10. And I can't go any further because there's no perfect square other than 1 that will go into 10. Okay, it works with division as well. I can divide any numbers outside the square root. I can divide any numbers inside the square root. So, let's see here. 6 divided by 2 is 3. And the square root of 18 divided by the square root of 2 is going to be the square root of 9. But hey, square root of 9 is a perfect square. That's 3, so this is 3 times 3, which is 9. So this is a weird one because I had a square root and a square root, and it came out to be a whole number, which does happen sometimes. Okay, so here's a worksheet for you. It's a couple pages. I will see you guys in class. Have a great evening.